Well, good evening all, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments Australia. We are really excited to bring you TI-Nspire Essentials. We see that many of you are joining us for the first time, so we would like to offer a special welcome if this is your first TQ Professional Development webinar. My name is John Bayman, and I am your host for this event. I teach mathematics to Year 7 to 12 students at O'Loughlin Catholic College, Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. I'm excited to introduce our panelist for this evening, Mr. Peter Fox.
Hello,
as you can
John,
see, Peter, Peter, he's so eager to get started. As you can see, Peter now works for TI Australia, but as a maths and physics teacher for 25 years. I know for a fact he is knowledgeable with all forms of TI technology, especially the computer algebra system. Peter, thanks very much for joining us.
Thank you, John.
I will now pass you over to Peter. Peter, thank you very much for joining us. It's all yours. Thank you.
Thank you. So the first thing I'm posing to participants tonight is to think about what year levels you'd like covered. You can use the chat space to make your preferences. So just in general, we're looking at, say, something from junior school. That's factors that count, applicable to Year 7 and or Year 8. All these activities can be bumped up or down, by the way. There's another one called How Long? That's in Year 9. Or there's 3 of them from our senior maths courses for general methods or specialists. They're in increasing degree of difficulty, if you like. So you can vote for something on the senior maths courses. I can already see some people voting for the Year 9 one and above. That's cool. And we'll come back to that. So they're the options. But in the meantime, since we're just starting out, what I wanted to quickly go through is some of the things that we need to be aware of when students first get their calculators. As educators, we often take these things for granted, but when the students are opening up the box for the first time, there's a few things that they need to know. So these are some of the things that we're going to have a look at very briefly before we start the activities. If the students are purchasing a calculator here in Australia, and I see we've got quite a few international participants on tonight, if you're viewing us from Australia, there's an option for students to register for an extended warranty. The details are on the box, and they should do that. It's well worthwhile. It's free. So it gives you a total of 3 years warranty on your product. There's a little barcode on the back, and just next to it are some product information that you'll need when you're entering that warranty information. Plus, we need to make sure we keep a copy of the receipt. You'll also need the serial number, which is located on the back of the calculator. It doesn't come up very good on the slide there, but no point entering my calculator number because otherwise you're just putting me for another warranty. So that's the serial number on the back of your calculator. And make sure you keep your warranty receipts. I suggest taking a copy of them. And John, you had a different idea that you do with your students, didn't you?
Yeah, well, most of our students normally have a phone with them, so I always suggest that they take a photo of it as well. That's always going to be kept on all the devices if they share the photos, so I think that's a very simple way to do it as well.
It certainly is, and it means they've got a digital copy, and some of those receipts are heat sensitive, so they kind of fade with time.
That's right.
The other thing that students have been known to do from time to time is throw out that card that you see on your screen at the moment. Even though it says on the top, do not discard, perhaps we should have written on it, don't throw this bit out. That might have made sense. It's actually got a copy of the serial number for their software. So if they throw that out and never register their software, there's nothing TI can do to recuperate it. So make sure you keep a copy of it, and maybe, as John suggested, take a photograph of the serial number for your software license. The other thing, not many kids throw this bit out because they see this as physical product. It's the calculator cable. They often call it the charging cable, but it will only charge if you have the software on your computer or you have a wall plug to do that with. That's the only purpose for this cable, is to connect it to your computer, your calculator to your computer, or the calculator to a wall charger. The other cable that they'll see in the box is a short or a small one, which obviously they use to transfer files from one calculator to another, or even update their operating system. But it's a communication cord between two. This one is hard to replace if they use it, because there's not many shops that sell that one. The other one is essentially just a generic USB cable. Whilst we're on the options for charging the calculator, talking about connecting it to a computer, that's one way to charge it, but it will only charge if they have the software installed. If your students have lost the software, or as one school I know in Queensland does, they wanted to install something on every student's computer that was free, and you can do that with something called the TI-Nspire computer link software. That's free. You can install it on every single student's notebook computer. It's easy to install, and therefore that means that when they connect their calculator to the computer, it will actually start charging it, assuming the computer's on. We've had people do that. And obviously the wall adapter, as I mentioned, you can plug your calculator into a wall adapter. If you're using one that's different than perhaps the one you see on the screen, it's not a TI one, we can't guarantee that it's going to charge the battery. Or in some cases it may charge it too rapidly and damage the battery. So you're best to use one of the ones that's designed specifically for it. If you're in a school situation, then you might look at a docking station. Very convenient that you can plug up to 10 calculators into that device and see the charge status of every single one. Most teachers actually just see it as a charging station, but there's actually a USB port on the end of it, which means you can also send files to 10 calculators at once. And each time one is taken out, another one put in, you can put more stuff on it. It'll automatically keep transferring your files.
The nice thing about that, Peter, is it's if you have them as a class set, it's a really nice way to keep track of where all those calculators are.
Oh, and so you don't have to count them. You can see when there's one
look
missing.
around, all 10 are there, job done.
Yeah, that's
very
true.
Yeah, with the volume purchasing program through TI Australia as well, that makes it much more affordable as well. So that's another thing that people could look at.
Yeah, look, I'm with you. I used one when I was teaching, and I don't know how people really cope without them, because we also had one sitting in our library so that students that had a maths class and they didn't have their calculator charged could go in there and leave their library card or whatever it was with the library technician, and they would just pop it on that. Well, they don't call it a library anymore, they call it a resource centre, and they would just pop it in the charging bay for them, and they'd come back and get it at the end of lunchtime or recess whenever it had a bit more charge on it. You can also update the operating system using those too, very handy. So now let's have a look at the calculator keyboard. Now I know most people will be familiar with this and be wondering why I would bother spending a couple of moments talking about it. But again, if we're looking at students new to the calculator, there's a few regions on the screen that I'd like to draw attention to. The first one is this little section here, which I say to students, this is your navigation area. You'll see the tab and escape key similarly positioned on a computer keyboard and perform similar operations. Like you can tab around a web browser, you can tab around menus in the calculator. The escape key does exactly what we'd expect it to. There's a document menu, and the navigation pad, it's all in the one spot. So when you want to move around the calculator between files, documents, applications, that's the best place to do it. The next section is really what some people like to call the calculator bit. It's where all of the maths functionality is located. Your trigonometric functions, squaring, square rooting, basic operations, and there's even a template key, which I'm sure most people are familiar with, but that's your focus when you're actually doing the mathematics. Then the final bit is these alpha keys, but there's also a couple of little extras on either side. Probably the most common question we get is, why don't we have a QWERTY keyboard? Well, there's a couple of reasons. One is that that's a very localized idea because not every country has the same keyboard layout, by the way. But the second reason is QWERTY keyboards on calculators are banned in a lot of countries. So had we arranged them in that QWERTY order, it would not have been allowed in quite a few countries. I know that sounds a bit weird, but that's the way it is. But you'll also find punctuation symbols such as an exclamation mark, which we know can be a factorial key, and a few other bits and pieces in there, plus some of our transcendental numbers like E and pi are sitting in there. So that's where you can get those, and X, Y, and Z prominently located down the bottom there. So it's worthwhile making sure students know those three zones, I call them, for the calculator. They're pretty good with the top bit, which is the screen. The other thing I wanted to show people tonight is some of the common shortcuts. So I always encourage students to save their work. So Control-S, the same on a computer. Now I say PC, but you're a Mac user, aren't you, John?
Well, actually, I'm bi. I use both. I keep flipping between them both. But yeah, I think that, most of them are sort of similar-ish, and you sort of get used to both the more you use them. I remember using the Mac for the first time and sort of going, where is everything? And then it becomes second nature, and then you start getting frustrated with the with my other versions. So I think these are fantastic, these shortcuts, and the kids love them once they know them, and they're so obvious that they're fantastic.
Yeah, and so on a Mac, is it Command and S to do save?
Like I said, I only bought the Mac just after Christmas, so I'm still in its infancy. Yeah, treat me gently there.
I'll let you off the hook with that one then. That was a question without notice. Sorry about that. And then other ones that, of course, for editing, your undo. That's one of the most popular ones. I know if teachers started out with the TI-84, they always asked, where's the undo button? And now we have one, which is kind of cool. And there's a redo button as well. Control and Escape also does undo. I notice a lot of people use that one, the same as it is on a computer. And then they say, well, how many times can you undo? And I say, well, you can undo it 99 times. And you can undo a redo and get all messed up too. Copy, paste, Control-C, Control-V, all of those things work the same as they do on a computer, and obviously some calculators. So let's go back now to that first option so we can start having a look at some activities, because I'm sure that's why most people joined us. I didn't do too bad. I think we got through that in about 10 minutes. So,
great.
John, what's the options coming in on our chat space? What are they telling us?
Not that you really would like to hear this, but quite a wide spread. It's fantastic, actually. We've got everything from teachers who teach Year 9 all the way up to teachers who teach Year 12. Probably a slight movement towards the senior school. But, yeah, just to see if you can squeeze it all in, Peter. A flavour of everything would be fantastic if you could.
All right. Well, we'll start with, we'll go right in the middle there with the pendulum swing. It might not be the thing that teachers would first do, but it does give you some idea of the capabilities of this thing. Now, when people logged into this webinar, and they'll be able to do it afterwards, that's fine, you'll notice that each one of these things is underlined as a hyperlink. So teachers get this PowerPoint slideshow in the webinar handouts, and it will be available on demand with the handouts. And what I've done is, rather than bundle all the activities into the download, I've just put the hyperlinks to them. So when teachers actually click on any one of those, let's be adventurous and see what happens if I click on it, shall I? I'll see if my computer automatically jumps to it. Oh, there it goes. And there's our, and there it's off and racing. That little pendulum's going already. See how easy that was? So this is the Australian TI website. Some people will be familiar with it because they used it to register for this webinar. So how did we get to this particular place? I'll go back to the home page, and we have a huge section for teachers, and because we've jumped onto something in the senior curriculum, I'll click into that one. And this one I know is located in the Victorian curriculum, but it's also common to other areas obviously, and this one is from Year 11 Mathematics and Functions and Graphs. So you can see there's a few options down there. And this one's pendulum swing. So if you're not familiar with the Victorian curriculum, if you're from one of the other states, you could try locating it in your region. Or just jump onto our activity exchange, which I'll show you. Teacher Learning Centre down here. And you can do a search through the whole entire database of activities rather than being focused on the actual course name. Over on the right, you'll see that we have the option to download the student file, the answers, download all of them at once. That's not all that impressive when there's only 2 of them, but some of these activities will have 4 or 5 things related to them, so that's just a zip file which you download. Alright, so what I've got on my computer, let me see, I've got them all loaded up, so I was ready. Pendulum swing. So when you download that activity, this is the sort of thing that you'll see. Let me just get it up to the top. So there's a little bit of an introduction. There's some teacher notes and answers that go with it. In this particular one, the answers vary a lot because it's relying on the data that students collect. Now, unfortunately, the pendulum that I'm showing there is from, well, used to be located in Canberra, the Questacon Centre there, but it's now been moved to a university somewhere, I believe. So unfortunately, people don't get to see it there. But let's scroll down a little bit further. It gives us some information. The fishing float that I'm about to use, and people look at me weird when I'm carrying it around to class, I recommend getting one about 30 centimetres. You can get it smaller. I've just found that the most consistent results come from a fishing float. Not the sort you dangle in a line. This is the one you'd attach to a net. Vary in price from about $10 up to $20. And it holds onto the string nicely, and it gives it a really good target for our motion detector, which you can see over here on the right. So, how do we collect data? Teachers are probably thinking, oh, that sounds a bit tricky. It goes through all the steps on a calculator, gives some initial questions. I'm not going to go through every single question in the activity here. We won't have time for that. But what I will do is demonstrate the activity. So I'm going to jump across to my Nspire software, and all I've done is just started a new document. I've put a calculator application in there, done nothing else, and now I'm going to plug that little device in which you saw on the screen a minute ago called a CBR. It plugs directly into the calculator, but also can be plugged directly into your computer. And I didn't press any buttons. The software or the calculator will automatically detect that it's a CBR and will start up the software accordingly. Now you can see I'm in a very small room. It's 1.22 meters away from a wall. But now I'm going to juggle my computer, the phone, and a pendulum. So just bear with me for a second, folks. I'll put my phone down and we'll collect some data.
And this is a fantastic way, isn't it, Peter, of showing the students as well, rather than just having it on their handheld, to actually have it in front on the big screen, even if you haven't got Navigator, is such an easy way to demonstrate it to the students and get the students involved and get them out of their seats. He's obviously busy collecting data at the moment.
Well, as you might have seen, I had 2 shots at that data collection there. I'm going to live with that second one that I've collected. It won't be as neat as what I hoped, but you can see we get the general idea. The top graph that we're seeing there is position time. The next one's velocity time, and underneath it's actually also stored acceleration time. The activity that I've got that we're doing tonight, that's actually just for position time, but if you think in calculus or anything else, then you can also look at the velocity time information. Now I just use one of my keyboard shortcuts there, Control-I, and I'll put a graph application in. I'll also disconnect the CBR because it's still ticking away. Now normally when we start up a graph application, we get exactly what we'd expect, the option to type in a function. What I need to do is change the graph entry type to scatterplot, because I want to plot the points that we just collected so I can put a graph over the top of it. And you can see it's automatically named the variables with sensible names. Run 1, meaning that's the first lot of data we're collecting. And on the x-axis I'll put time, and on the y-axis I'll put position. And there's a little worm down the bottom. So I'm just going to hide the label there because we don't really need to see that. I want to focus on the data. Now there's a couple of ways you can do that. It tells you all of this in the actual activity itself. But I'm going for the lazy man's option first, and I'll do a zoom data. So I can see a better idea on the sort of data that I collected. But what I don't like about that is I can't see the x-axis. And I think conceptually this is important for students to be able to see that. So I'm going to fine-tune the settings just a little bit and do some manual operations on this. If I put something like negative 0.1 in there, I think that's a bit clearer for students to see what's going on. I could have changed my settings in there as well for where the hash marks are. I'm going to cheat and just double click on it there because that's easy to do on the computer. And if you wanted to, and I'll go back in here and I will change it back here now that I've said that, because you can also set, say for example, a scale of something like pi or pi on 2 if you want to do just as a demonstration. So we can see our scale says pi now. In this activity, I'd actually prefer to have it in 1 second increments. Now, the other thing before I go any further, always good to check what mode you're in up here, radians. Now on your calculator, if you're not familiar, there is a settings menu in this window which is separate from your entire document settings. So we can change your graphing mode because you'll see that the most common setting for geometry, for example, would be degrees. But I'm choosing radians for my graphing angle. If my calculator was set up in degree mode, this would now say degree up here, but it would say radian when I change to this application. So now I'm ready to type my equation in, but I'm going to need a few clues first. So what the activity suggests students do is put in another graph, but this time it's going to be a function, and I'm going to type 0.4, and you'll see why in just a moment. The whole idea of this technology is to provide a much more visually impressive tool for students to gain a better conceptual understanding of the mathematics. So what I'm going to do now is you can actually drag and move these lines down. Even though I type the equation in, I can move that line. And I think that's probably close enough. So I think the vertical translation of my function is probably 0.31. And of course this will be a big test of my memory to see how much I can remember. The next thing I'm going to have a look at, and I know that first bump is a little bit off, so I'll miss that with my graph, but probably about 0.47 I would think. So let's start typing some stuff in. I'm going to start with a cosine graph. Oops. Plus 0.31 I think was my vertical translation.
Sounds good to me.
Translation parallel to the y-axis. And I think the peak was about 0.47, so I'm going to take 0.16. Now here's the interesting thing. Some students might type in 0.47 as amplitude. Let them, because the graph will show them that that was wrong. So you don't have to jump in and tell them. That's not too bad a fit, is it, really? Well, we probably need to do some transformations parallel to the x-axis, I'm thinking. So I can actually delete that equation off there now. And here's something some people may not have seen yet. This was introduced recently, and that's the ability to graph a relation. So I can type in x equals 1. It's not exactly where my graph starts, but if I move along to about the middle of that line, I'll just drag this over here. And now you can probably see why I chose a cosine graph, because it's easier to line that up than what it is to say, well, my sine graph starts about here somewhere, and just to throw the odd spanner in the works. So I think a 0.66 translation for this graph might be good. I'm going to type in here minus 0.66. So we can see that this point here is now aligned with that one up there. So we have one more thing to do, and that is looking at the period. Now here's one where, and the reason why I kind of like leaving the seconds across the bottom. I get the students to imagine that pi is about 3, and I say, so how many backwards and forwards swings, complete swings, would we be looking at in 6 seconds? You can actually set up the motion sensor to record for 6 seconds. I'm quite happy with the 5 because then the kids have to do a bit of visualizing. So I'm going to say 1, 2, 3, almost 4 I'm thinking. So I'm happy with an approximate here. I'm going to say I think it's about 4, and I'd better pop some brackets around that. And we're not too bad. Well, what do you think, John? What do you think I should do to my equation?
I reckon you should grab it and drag it to the left.
That would be cheating.
Oh,
I think I'm going to change the period just a little bit so we can see that's improved. And this is kind of like the extra practice. And I didn't try this earlier, as in this is real data that we collected, so that 4.5 guess is pretty reasonable. 4.6 perhaps a bit too much. And the students, believe it or not, will experiment for quite some time trying to get that data to match as well as possible. And the little mathematical trick is just do this. Just make the line really thick. That will make it a better fit, right?
Beautiful.
So that's one of the activities that, yeah, it's good, isn't it? It matches much better now. All we could do, as John suggests, we could just grab the graph and slide it up, but that's not the point of the activity, and perhaps best not to tell the students that at the start. But there's questions in the activity that say, how did you derive this and where did that come from? So that's not too bad. That was one of our senior maths activities done in about 10 to 15 minutes. So that gives us enough time to do some more. So that one, as I said, that's available from our website, and it's called Pendulum Swing Position, and you can see it's taking us through all the steps that we did there. The one that I've got on the screen actually shows them setting it between negative pi and 2 and 2 pi, but those things are up to you or your students depending on what they prefer. And it goes through step by step. Now look, one of the advantages of this activity is that every single student has a different data set to work with, but they're all doing the same mathematical task. So that's kind of cool. And as I said, it collects velocity information as well, so if you want to bring some calculus into it, you can talk about rates of change and how the velocity time graph relates to your position time, and all in a context.
And Peter,
Right, so
if the students were, if you're fortunate enough to have more than one CBR2, like you said, it's really interesting for the students to see the different graphs of each other's. Either you could get them to take a screenshot of that and send it to you to show next lesson, or something I was doing recently, it's a very simple thing, is having something like Air Server on my computer and just getting the kids to connect using their phones and just do a live camera of the actual screens.
Oh, that's cool.
If you don't have, obviously, Navigator.
Yeah, yeah. The good thing is, like you mentioned about one CBR, and that's an excellent point, is that I think the maximum number of CBRs I've ever had with my class was 2, but you saw that the actual data collection process was about 5 seconds, maybe about 1 minute to set the entire thing up from start to go, giving them a chance to redo it. And students could be doing another activity, so I'd have students answering some other questions as they're going, and I'd say, right, make sure you save your data, we're just about out of time, and I'll see you next lesson, and we'll bring the data back. Because don't forget, you can save the data, and then it saves it in the document, and you can open it up next lesson.
Exactly.
All right, so what was the next preference, John? We've done one from, we can come back to senior, we've got plenty of time.
Yeah. I reckon go for a Year 9 one if you can.
Okay, let's have a look at how long. So how long is located on our Australian-inspired curriculum site? Australian Curriculum Inspired, and you can see we can pick up by year level. And for those of us that are joining us here in Australia, they're the Australian Curriculum Standards, and they're the ones that this activity actually addresses. In this particular case, solving 3D trigonometric problems is one of the extension options. So not necessarily covered if you just do the basics of the activity. So let me just bring that activity page up, and this is what it will look like if I scroll to the top. There we go. So here's the essence of the question. We have a 1 by 1 square, and we randomly place 2 points inside the square. I want to know that if I repeated this process, what do you think the average distance between those 2 points might be? So John, did you want to take a guess? Another question without notice. So it's a 1 by 1 square. We randomly place 2 points inside the square, and we want to know if we repeated that process, what do you think the average distance between those 2 points might be?
Oh my goodness, the average distance between the 2 points, I reckon 0.5.
That's not a bad guess, is it? Because you'd say, well, the shortest thing would be 0. The probability of that would be pretty slim, right? The only catch is the longest distance, and you'll see that some of these questions are actually posed in the sheet. What would be the longest possible length? Well, that's a simple one for students to do, and this one's obviously based on Pythagoras' theorem. They'd see 1 by 1, so root 2. So we might start to think, oh, it's probably a bit more than a half, but that depends on these probabilities, doesn't it? Now, believe it or not, that question is not able to be answered even in our standard Year 12 mathematics courses. It requires 4 integrals, 4 consecutive integration problems, so it's not the sort of thing you'd want to tackle within a month or so, but we can simulate it, and this sort of demonstrates the power of simulation. But what about the mathematics? What mathematics are students doing? So you'll see here, we get the students to simulate it on the calculator. So let's have a look what file comes with it. What's the TI-Nspire file that comes with it? Now look, here's one I prepared earlier. So this is the one that you download when you get it off the website. And the students can just click on here and get a sense of whether or not they're right or wrong, and just record the lengths and take an average. Still haven't done anything to do with Pythagoras. Some pretty simple mathematics going on here, but we want to get a sense of what the actual answer might look like. So there's a mixture of probability and algebra in this activity. So let's go back to the question sheet and have a look. So it says, let's create some samples. Oh, and the initial part, if they don't have the calculator file at the start of the lesson, sometimes that takes a bit of time to distribute. There's 8 little samples which they measure with their ruler as they're going. That, in part, is really designed to give the teacher enough time to transfer that file to each calculator if they don't have Navigator or the docking station that John has. Once they've got it, they run the simulation, and then it says, well, let's see if we can come up with a rule. Here's a diagram, and this may be something that the teacher's either given them before, but this activity gives them the option to do it for themselves by including a diagram and applying some Pythagoras' theorem. And then we go into that space that not a lot of teachers like. Students seem to love it. And it says, use the scratch pad to generate 4 random numbers corresponding to x1, y1, x2, y2, and record the points and plot them on the Cartesian plane. So this is really just giving them a mechanical way of actually doing it before we do everything on the calculator. So they can do that and then measure the actual distance. So it's scaled, measure the actual distance and record your results. And now it says, all right, let's create a larger sample. And here's a bit more where the students get some experience by hand. So let's go into the calculator and follow these operations. You can see the lists have already been named, x1, y1, x2, y2. Look, you can actually name them with a subscript. Let me just show you what that looks like. I chose not to because I figured that, let's just put that in. I figured I'm just complicating it a bit much. So you can actually put a subscript on these things, and it looks a bit better. And it will come up in your menu and go, oh, I haven't labelled it, have I? I should have stored something in that one. Let's make it equal to 0.2, and then you'll see it appears in there. So you can actually then use the formula as you'd see it written by hand. But in this activity, I just thought, no, don't want to complicate it. So the first thing we need to do is generate a random number. Now the spreadsheet works the same, if you like, as an Excel type spreadsheet. If we're going to type in a formula, we need to put it in with an equal sign. If I put the formula in here, then that would apply it to the whole column, which is thousands of cells long. That's not a good idea. It's useful in some spots, as you'll see, but for now, I'm going to put in equals, rand, and that's it. Now I could have picked that up from the catalogue, so let's go across here, and I can use equals, and I can go to my catalogue. Oh, look at that, I was working with Fahrenheit last time. And if I click on R, then I don't have to wander down very far, and I'll find that random command there. We saw earlier on the webinar, there's some nice little tricks. Control C, go across to here. Now this is cool because, is it going to paste 0.849? No, it pastes the command, so it's actually pasted in the formula. And it remembers it, so if I do Control V again, which is paste, or under Doc, Edit, Paste. And if you didn't remember all the shortcuts, there they are there.
There they are.
So, now we've got those, oops, we can regenerate them as often as we like. Control R, I think, from memory. There they go. Control R will regenerate those random points. Ah, look at that. I've got a column called distance. Now, here's where we can work with that formula up the top. If I type the formula in here, it's the same as Excel. You would need to fill the formula down. However, if you want to apply a formula for a column, it does something very logical and sensible, and that is it will only apply the formula where those cells that it includes are occupied. You'll see what I mean. So our distance formula says the square root of, and another little tip for everyone, your variables can be captured from in here. So we'll do x2 minus x1 squared.
Now, Peter, you're pressing those buttons quite quick. Can you explain to people where where you found that variable from, just so they won't have to catch it?
Oh yes, thank you, John. If you press the variable button on the keypad, it will list all the variables that are defined, including lists, and you'll see that the lists have a particular symbol. They have the little curly bracket notation that tells you that it's operating with a list as opposed to a single value or an equation. So I now want to do y2 minus, and again I'm just hitting the variable button, y1, close the bracket, and our squared sign is over here, and press enter. So it's calculated the distance for us. So let's try it again. Control R, and it's doing what we'd expect. It's renewing every single random number, and it's also recalculating the distance. So what? All right, I want to take a sample of a few of them. So I'm just going into the menu, and there's my favorite from Excel, Phil. His brother Phil Downer's not there, but never mind. That was a really crummy joke, wasn't it?
I'm not going to answer that one. I'm just lucky that everybody else has been muted at this end, on the other end, I reckon.
That's it. You're probably right, because I think they all just groaned. Now, I just quickly jumped off the error message there. What the error message is telling us is that there's a formula that would like to use those cells now because it's seen that there's some more data going into cell A2, A3. That's my distance formula over here, and it's saying, yeah, we've got a problem trying to calculate this stuff because it's not contained in every cell. So this is a bit difficult to do on the software if I'm just using it as an emulator, but I'm using my computer keypad here. If you press the shift key and arrow to the right, we can still do the menu and fill down. Fill, and then just arrow down.
Nice.
There's a few more random numbers. Now, notice what's happened with my distance formula. I didn't have to fill it down. That's because I typed it in up here. If I typed it in here, I would also need to fill it down. So we've generated, what was it, 5 samples or a few more? 6, 7, 8, 9, 10. So we've got 10 samples there. So next thing I want to show people is this numbering system on the tabs, 1.2, 2.1. Page 1.2 is where my little simulation occurs. Page 2.1, it's problem number 2, page 1. So if I insert a calculator page here, it will see the variables I have on page 2.1. But if I go back, and I'm going to do it this way so people see how the students can navigate. That was control and then the up arrow key. If I go back to here, there's my little simulation, and drop a calculator page in, and I'll press the variable button. X1, X2, Y1, Y2, they're all there. That's because I used them in the simulation, but notice there's no distance thing there. So I reused my labels because they're common to both, but you'll notice the distance one is not there. You'll notice that these are only single values now. They're not lists. So it's not actually the same variable, really. Whereas over here, you'll see that those variables are lists because they've got a different icon next to them. And if I press enter on the first one, I can see on my calculator application all the values that are typed in that spreadsheet. So I could add them up like that, type in sum, or let's have a look in the menus. We might want to do some statistics, stat calculations, or if I just want a specific one, such as the mean of all those values, all those distances, 0.43. So that suggests to me, John, that maybe you're right, maybe it's only 0.5. Now, one other thing that people may not have seen before, and I wanted to try and cover as many of these applications as possible, is my notes page. You can type stuff in, but I'm going to put something in called a maths box. Control M, M for maths. And I'm going to use my catalogue to go and get that calculation now for the mean. And we'll use our variable menu to find our distance and press enter. Same thing, no difference. Except if I come back to page 2.1 and re-simulate those, let's compare what we see on the calculator application, same as what we saw before. So the calculator page is like history. It's not dynamic, it's not updating as we move. However, the notes application does. You can see our mean has changed to 0.41. So let's re-simulate again.
That maths box is a fantastic little feature to use in notes, isn't it?
It is really good, particularly for things like this where you want it to continually update and capture the new information, because it's too easy for students to look at that calculator page and go, oh, it's not working. Look, all they have to do, just to show that it is actually working, is you can do that. That will work.
That's right.
But you're right, the notes page is much clearer for that. I mean, look, the other thing you can do, you can actually split a page. This is getting a little bit advanced. You can split a page. Let me just drag him down a little bit. put my notes in there and do the mean. I'm cheating now because I'm using my computer keypad. And then back on here and Control R and watch them update live. I mean, for that matter, you could type in mean of distance and put it in a cell.
Yeah.
This is just a different way of doing it. So look, I don't think you're that far off by the looks of those. Do you, John?
I don't know. I haven't seen this activity, and I didn't think too much about it, so I think you're stitching me here, to be honest with you.
Look, when I first did it, I thought, I'm thinking 0.5, and then afterwards I thought, but I can get some longer than 1, so I'm thinking maybe a bit more than 0.5. And look, the answer is not obvious, and that's kind of one of the reasons why I like the question. It's just some random weird, well, it's not random, it's mathematical value, but it's like the natural log of 5 plus something square rooted. It's weird.
Spoiling up, I have to say, I'm doing Pythagoras at the moment with my year 9s, and I have to confess I haven't seen this activity, but it made me think, oh, I could use that tomorrow. And like I said, I don't need my kids to have the calculator as such. It's just a nice discussion, perhaps at the start of the lesson or even at the end of the lesson. Now, if I run it as and you can see how easy it is just to open it from the TI website and just run it and see what the kids say. It's just a nice little discussion.
Or look, if you're even using a scientific calculator, they have the ability to generate random numbers, and then you could just drop them in.
Yeah.
And plot them on a grid, the same as what we did before, and get the students to do the distance calculation by hand, which is just practicing Pythagoras' theorem in all reality, isn't it? Set them up with a table and get to do it step by step.
Well, that's right, and even on the TI-30 with that lovely little, so it's sort of a simplified version of this, you can still run it exactly the same on that calculator in the stats page.
Oh, that's true. Oh, I hadn't thought of that one.
Oh, yeah.
See, now I'm going to have to rewrite the activity, John. You're making more work for me. That is good. I like it. Thank you. All right, so that's how long, and the extension says to them, all right, so what if we change the dimensions of the box, and it's not hard to change the random number generators, or if you wanted to apply Pythagoras in 3D, what if we had a 3D box? What would be the longest length of the rod that would fit inside a 1 by 1 by 1 box? And what would be the average length if we're randomly placing that rod in the box? So that's the extension activity, and look, I'm a big advocate for stuff where you can push the activities well beyond where that curriculum is currently sitting to give the chance to some of those top-end students to really go off and explore. And if they go off exploring on the web, they'll get scared by some of the fancy mathematical notation, but there's some nice patterns that start to appear in the data as you have a look at the different dimensions of the boxes that are possible, whether they be 2D or 3D.
Now, Peter, you've got just under 10 minutes, so we're hoping that you may be able to show us one more briefly, if that's possible.
Yep. All right. So if we don't have any preferences from the audience, and I'll throw it to you, John, what would you like to see? We've done pendulum swing, and we've done a year 9 how long?
Well, let's go to either Monopoly or squares and cubes. I'll let you choose.
All right, well, the Monopoly...
Somebody just typed in and said Monopoly, please, Peter.
And I just saw one that says specialist, please. Ooh. How about I do them really quick then?
I'll see if I can get the year 7 comment as well. Thank you for these replies. I really appreciate that in the chat window.
We'll have to do another webinar, John. So look, the activity from the senior curriculum, let me just jump to there. I'll do the Victorian one because that's the one I'm most familiar with.
I think it's also best if you don't actually show them all, because then it will give it'll give them an excuse to actually go and look for it after this webinar tonight as well.
Oh, well, that's very good. That's true, yes. So I'm just, there it is, Monopoly. So they can download the Monopoly one. And look, there's actually a lovely YouTube video on the data in Monopoly, and there's some amazing investigations. So, for example, what is the best properties to buy on a Monopoly board? And it's actually bizarre. These guys have simulated thousands and thousands of rolls. They did it practically. And then one of the mathematicians who did a PhD, would you believe, on what is the best property on a Monopoly board, because there's so much mathematics inside it. So look, the activity, they download the activity. There's so many different things that you can explore. The activity, because as it says, it's only part one, we want to find out, is there some sort of relationship between the spaces from Go and the rent or the price that you might pay for that property? So let's have a look. Oh look, somebody's typed it in for me. Oh, that's nice of them. So here we have spaces from Go and the property price. So I'll insert, I'm using that menu, I should use this one over here. So far I've done Control-I. I can also go into Doc and Insert, and we'll insert a Data and Statistics page, number 7. I mentioned before that the Tab key is really cool. If I press Tab, look at that, it jumps straight onto my X variable. And let's put spaces from Go. Nothing exciting there. But if I press Tab, I can jump straight across, and let's put in, what did I say, price. That's remarkably linear, isn't it?
Like that.
Yeah, it's not telling us a heck of a lot, except we can see that perhaps the Monopoly is a little overpriced considering where it is from Go. But in actual fact, if you do the reverse of this investigation in terms of real property prices and distance from the CBD, which I have as an activity, the line goes the other way. The further you get from the CBD, the cheaper the prices go. And if you assumed it was linear, at some point the government's going to pay us to buy the property. And in some country towns in Victoria, they did pretty close to the same to try and convince people to go out there. Now, there's add movable line because of our times. I'm just going to use regression and show a straight line. And the students then have to interpret what's going on here. What does it mean, 8.5x plus 39? In other words, if you could buy Go, it would cost you $39 perhaps. And then they can substitute values in for X to see how accurately does this actually predict the prices of the properties on the Monopoly board. Now, this is only one part of it. And this time I'm going to go to the home screen and I'm going to add in another Data and Statistics. This time we'll search price versus rent. Now before I click on the rent, do we think this would have a positive or negative correlation? The more I pay, the more rent I should get, right?
You'd like to think so, wouldn't you?
Yeah. Now what does that say this time about the Monopoly square? Now see how we're actually getting students to interpret the graph? Normally they just go, yeah, that point's off. But kids so want that Monopoly square. It's like the prized possession. It gets the maximum rent. Does it? Is that what it's telling us right now? What the points above and below our linear regression tell us? So, as John suggested earlier, I'm not actually going to answer that question. I'm going to leave that to participants to figure out, is Monopoly a good investment? Monopoly. Is the last square, Mayfair, on the Australian board, is that the best square? Well, actually, that's the UK version, isn't it? But it's the version I most know is the Mayfair. Is it really the best one? And then, of course, you can have a look at what happens if you buy all the properties in that property group. Does that make any difference? So, I'm looking at the time there. We've only got a couple of minutes to go, John. So, yep. I think we've got enough material left for another webinar.
No, I think that's great, Peter. I was just thinking, I've got it on my screen, but obviously I think to just reiterate that all the supporting documents as well is on that website.
That's right.
If people wanted, like sometimes you think, oh, well, yeah, that's great, but I've got to actually produce it all myself. Well, we can see on here that, I'm just going to take it back off here.
Yep, sure.
That we can see here that the PDF documents are there. So when they actually open the PDF document and it opens up, all the supporting documents are here.
You just want to share your screen there, John? We're seeing the...
I apologise. I was there, right, so I could see it. So thank you for...
Right. But you're cheating. You're hiding it from us.
There we go. Is that a bit better?
Yep.
You think I'd have learned, wouldn't you, after all this time? So, and thanks, Ben, for noticing that as well. giving me a heads up. So I just clicked on the PDF document here, and I'll just open that up. But yeah, all the supporting documents to give out to the kids is all there. Really takes the pressure off the teacher to prepare the lesson, and it's just there, and you can let the kids run with it either when you're taking the class, or even sometimes as a relief lesson as well. It works quite nicely. And the good old favourite, the answers as well, which we all love to have. Okay, so to wrap things up, thanks so much, Peter, for an informative webinar. We're going to begin wrapping things up, as I said, and if you have any last-minute questions, please try and get those asked, as I know Peter will endeavour to get them answered. When you leave the webinar tonight, a brief survey will automatically appear here in your browser, and your feedback guides us as we plan future online events, and we'll listen to your feedback, and we hope you'll share your thoughts in a post-webinar survey. Your certificate of attendance will be emailed to you in the next 48 hours, and believe me, that's true, because I received them when I do mine as well, along with a link to both the on-demand and the YouTube version of the recording, as well as any other relevant documents that Peter mentioned tonight. So after tonight, if you do feel that you'd like any follow-up, please contact us. I know that the people at TI Australia would love to hear from you. You can either phone them on those numbers, or you can email. So once again, thanks very much, Peter, for everything you've shared tonight. I really appreciate it.
You're welcome, John, and I just want to point out that someone did actually type in lol to my joke. So I appreciate the comments from that person. They obviously understood my warped sense of humour.
Either that or your mum's been on the webinar again. I'm not sure which. Hey, which is what's going on there. It could be. All right, so thanks, everyone. Oops, this snuck onto the other one there. Thanks, everyone. We hope to see you back online soon, and have a great night. Good night.
Thank you.